Hello students and welcome to my channel Maths App. So in this video, I will be telling you about the change of variables, that is converting Cartesian system to spherical polar coordinates. So I would request you to kindly check my previous two videos on change of variables, where I've talked about changing Cartesian system to polar coordinates and converting Cartesian system to cylindrical coordinates. They will help you to understand that what is the concept behind it. So now in this, the variables, so already I've talked about these two in my previous video. So here I will be focusing on converting a Cartesian system to a spherical polar coordinate. So now when we are converting Cartesian to spherical polar coordinates, now what are this the coordinate system? The coordinate system in this is r, theta and phi, right? So when we work with r, theta and phi, so how do we convert x, y, z in terms of r, theta and phi? Let us see. So for example, let us take a point P in x, y and z coordinate, and now we will be converting our x, y, z to rho, theta and phi, right? How do we convert it? Now from the point P, we drop a perpendicular on the z-axis and we assume that the distance of this point P from the origin is rho, right? So this distance is rho, and now when we drop a perpendicular, so this distance is on the z-axis is z, and let the point P make an angle theta with the z-axis. Now let us take the projection of this point P on the xy plane and let that point be P, right? Let us take the distance of the origin from the point B and let the distance be equal to r. Let it be r, right? Now let us drop a perpendicular from point B on the x-axis as well as y-axis. So you can see that this unit, that is O to A, is x and O to C is y, right? So now in this right angle triangle, using simple trigonometry, we can see that r is the perpendicular, r is the hypotenuse, x is the base, and y is the perpendicular. So we know that perpendicular upon the hypotenuse is equal to sine phi, and this r is making an angle phi with the x-axis, right? So from here we get y is equal to r sine phi. And similarly, we know that base upon hypotenuse is equal to cos phi. So we get x is equal to r cos phi, right? So we get these two values. Now, since I've dropped a perpendicular from point P on the z-axis, so if I complete this parallelogram, I will see that this and this are the two sides of the parallelogram. So if this is r, this will also become r, right? Now, if I again apply trigonometry to this right angle triangle, this is a right angle and this angle is theta. So I can see that this is the perpendicular, this is the base, and this is the hypotenuse. So I can say that z, that is base upon rho, is equal to cos of theta. So z comes out to be rho cos theta. And similarly, r upon rho is equal to sine theta. So from here, r will be equal to rho sine theta, right? So we get the value of z as rho cos theta and we get the value of r as rho sine theta. So now let us evaluate this value of r here. So we get finally y as rho sine theta sine phi, and we get x as rho sine theta cos phi, right? So with the help of these transformations, we get the values that how we convert x, y and z in terms of r, theta and phi. Now what points do we have to keep in mind? Rho is always the distance of the point P from the origin. Theta is the angle that OP makes with the positive z-axis, right? So this angle is theta. Now sometimes you may find that theta and phi are interchangeable. In some books you will find that instead of theta they are writing it as phi. So you have to be very clear that what is theta, with which axis it is making that angle. So theta is always the angle made with the positive z axis, and the maximum range of theta is always from 0 to pi, right? And phi, it is the angle from the cylindrical coordinate. So when I take the projection on the xy plane, so phi is the angle made with the x-axis, right? So the maximum range of phi is always 0 to 2 pi, right? Since theta is the projection, so when we make the projection on the xy plane, so whenever theta moves from 0 to pi, you will see that the projection you will get on the xy plane is a complete circle. So that is why the angle phi is always from 0 to 2 pi, and theta, the maximum range is from 0 to pi, right? Now, when we are converting a Cartesian system, so suppose we have this system in f of x, y, and z, and we have dx, dy, dz, any order we can have. When we convert this in terms of spherical polar coordinate system, so what do we get? Instead of x, y, z, now the new coordinates will be rho, theta, and phi. We will get a Jacobian of the transformation, and we will get d rho, d theta, and d phi. So now let us try to see what are the values of this Jacobian. What will be the Jacobian of transformation when we convert a Cartesian system to a spherical polar coordinates, right? So now let's calculate the Jacobian of the transformation. So to calculate the Jacobian, we have the old system as xyz, and the new system is rho, theta, and phi. So according to the definition of Jacobian, this is del x by del rho, del x by del theta, del x by del phi. Then we have del y by del rho, del y by del theta, and del y by del phi. Similarly, the third row will be del z by del rho, del z by del theta, and finally we have del z by rho, right? So now let us try to calculate the values. Now what are the values of x, y, and z? X is equal to rho sine theta cos phi. Then y is equal to rho sine theta sin phi, and z is equal to rho cos theta, right? So let us put the values in this determinant, and what do we get from here? Del x by del rho will become sine theta cos phi. Then we have del x by del theta will become rho cos theta cos phi. Then del x by del phi will become minus rho sin theta sin phi. Similarly, what is del y by del rho? Del y by del rho will be sin theta sin phi. Del y by del theta will become rho cos theta cos phi, and del y by del phi will become rho sin theta cos phi. And similarly, del z by del rho is cos theta. Del z by del theta is minus rho sin theta. And del z by del phi is equal to 0. So now, when we calculate all the values, when we solve this determinant will give us the value as rho square sin theta. You can check this value, and it will give us the determinant as rho square sin theta, right? So that means whenever we are converting a Cartesian system, that is f of x, y, z, dx, dy, dz, into spherical polar coordinate system, it will become f rho theta and phi. The Jacobian will be always rho square sin theta, and we have d rho, d theta, and d phi, right? Okay. So with this transformation, let us check out the question. We need to evaluate the integral, triple integral x square plus y square plus z square, dx, dy, dz taken over the volume enclosed by the sphere x square plus y square plus z square equal to 1. So whenever we have the questions on sphere, converting Cartesian to spherical polar coordinates become very, very simple, right? So with the help of these transformations, x is equal to rho sine theta cos phi, y is equal to rho sine theta sine phi, and z is equal to rho cos theta. When you square and add them, what happens? X square plus y square plus z square will become rho square, right? So this triple integral gets converted into rho square. This is rho square. Dx, dy, dz will get converted into the Jacobian, that is rho square sine theta. Then we have d rho, d theta, and we have d phi, right? Now, what are the limits of rho? The innermost limit we are writing for rho. So it's given that the sphere is x square plus y square plus z square is equal to 1. So when I put the values in terms of rho, theta and phi, I get rho square is equal to 1. So rho becomes 1. That means the radius of the sphere is 1. So radius will go from 0 to 1. Now, theta is the angle made with the positive z-axis, right? So what is the maximum range when it's a sphere? If the angle made with the z-axis is moving from 0 to pi, its projection on the plane, xy plane, will always be a complete circle, right? So it will move from 0 to pi. And where will theta move when I get a complete circle? So phi is the angle made with the in the cylindrical coordinates. So that will be from 0 to 2 pi. So now when I solve it, the innermost integral is with respect to rho. So I have 0 to 2 pi, 0 to pi constant. Integration of rho square is rho to the power 5 by 5, 0 to 1. And we have here sine theta, d theta and d rho. So this is 1 by 5. Then we have 0 to 2 pi. Integration of sine theta with respect to theta would be cos theta with a minus sign, limits from 0 to pi, and then we have d phi. So this is 1 by 5. I can take out the minus sign common. Cos theta, okay, let me put the integral sign here first. So we have 0 to 2 pi. Now when I put the limits, cos pi is minus 1, cos of 0 is also minus 1, and we integrate it with respect to d phi. So this will become positive. I'll have 2 by 5. Integration d phi is phi. When I put the limits 0 to 2 pi, I get my answer as 4 pi by, right? So I hope this question is clear. So now let us move to another question on changing Cartesian to spherical polar coordinates. Now evaluate the integral x square plus y square plus z square dx dy dz over the first octant of the sphere x square plus y square plus z square is equal to a square. Now, when I say it is the first octant, that means our x, y, and z all are in the positive coordinate, right? So now when I convert this into spherical polar system, first of all, the integrand x square plus y square plus z square gets converted to rho square. Then the Jacobian is rho square sine theta. Then we have d rho, d theta, and d phi. The rho square is a square, so that means the radius of the sphere is 0 to a. Now, since it is the first octant, that means theta will only move from 0 to pi by 2. And similarly, phi is also in the first octant, so phi will also have the angle 0 to pi by 2, right? So now that makes it simple. So 0 to 2 pi. Then we have integration 0 to pi. Rho square into rho square is rho to the power 4. So that will become rho to the power 5 by 5, 0 to a. And we have here sine theta, d theta, d phi. So now this is a5 by 5, integration 0 to 2 pi. Integration of sine theta is minus cos theta, limits from, sorry, this is pi by 2, right? This is pi by 2, this is also pi by 2, and we put the limits from 0 to pi by 2 here. So we have d phi. So I can take out minus sign common. I'll get 0 to 2 pi by 2. Cos pi by 2 is 0. Cos of 0 is 1. So the negative sign will become positive. A5 by 5. Integration of d phi is phi. Limits from pi by 2. So we get the answer as pi a to the power 5 divided by 10. Right? Okay. So now let us move on to another question. So we have to evaluate triple integral over the W region z dv, where W is the region above the cone x square plus y square plus z equal to z square, and below the sphere x square plus y square plus z square equal to 4 for z greater than equal to 0. So if I try to plot this region, if I try to get a rough sketch of this region, how will this region look like? Let's see. So this is my x, this is my y plane, this is my z plane. So there is a cone, and then the cone has been surmounted by a sphere, right? So this is your sphere, right? The equation of the sphere is x square plus y square plus z square is equal to 4. And the equation of the cone is y square plus z square is equal to, it's x square plus y square is equal to z square, right? So let's try to convert this in terms of spherical polar coordinates. So we have triple integral. Z will become rho cos theta. Jacobian is rho square sine theta. We have d rho, we have d theta, and we have d phi, right? Okay, so let us consider the limits one by one. So in this region, x square plus y square plus z square equal to 4, when I put the values, I get rho square is equal to 4, so rho is equal to 2. So the lower limit is 0 and the upper limit of the radius is 2. Now how to determine theta? Theta is the angle, it is the point that the z-axis is making, right? So let us take this plane as the yz plane. So let me draw the yz plane over here, and let us try to determine what would be theta. So in the yz plane, what happens? X is equal to 0, right? So when I have x equal to 0 in this equation, I get y square is equal to z square. So y comes out to be plus minus z. So if I plot it, y is equal to z is something like this, and y is equal to minus z is something like this. And this is how the sphere goes on this, right? So this is y equal to z, and this is y is equal to minus z, right? So now let us consider a point here as 1. So this point will also be 1. And this is angle theta. So if I just apply trigonometry, tan theta is equal to 1 by 1, so it is 1. So theta comes out to be pi by 4. So that means the limits of theta is from 0 to pi by 4, right? Now when I take the projection of this spherical object on the xy plane, it will be a complete circle. So theta will move from 0 to 2, right? So let us try to solve it. So this is 0 to 2 pi, 0 to pi by 4. Rho into rho square is rho cube. So we have rho 4 by 4, limits from 0 to 2. And we have sine theta, cos theta, d theta, d phi. So now this is 2 to the power 4, that is 16 by 4. So that will become 4. 0 to 2 pi, 0 to pi by 4. And sine theta, cos theta, I can multiply by 2 and divide by 2. So 4 divided by 2, and I'll have sine 2 theta integration d theta d phi. So this is 2 times 0 to 2 pi. Sine 2 theta integration is minus cos 2 theta by 2. limits from 0 to pi by 4 d phi. So 2 cancels. I can take out the minus sign out. 0 to 2 pi. Cos 2 theta, cos 2 into pi by 4 is cos pi by 2, that is 0, minus cos of 0 is 1 with respect to phi. So that is 1. And when I integrate it with respect to phi, I get my evaluation of this integral as phi. Right? So I hope you have understood this question. And now I'll give you some questions for practice. So do this question. Evaluate the triple integral 1 upon x square plus y square plus z square dx dy dz taken throughout the volume of the sphere x square plus y square plus z square equal to b square. So do try out this question and let me know the answer in the comment section, right? So practice one more question also. Evaluate triple integral z square dx dy dz taken over the volume bounded by the surfaces x square plus y square equal to a square, x square plus y square equal to z and z equal to 0. Right? And again, do let me know the answer in the comment section and try one more problem, that is use spherical coordinates to evaluate this integral. Right? Again, these are very simple questions. So do try them and do let me know the answers in the comment section. And if you have any doubts, do let me know again in the comment section. I'll do comment on that and I'll reply them. And if you like the video, do hit the like button. And if you haven't subscribed my channel, do subscribe my channel to get the latest updated video. So have a nice day and believe in yourself. You can definitely do it. Thank you so much.